Hi everybody, Dave here again with another rocket build. Today I am building the Madcow Rocketry Python rocket. This is one of their what they call warehouse kits, which means it just comes with the fiberglass parts and not with any of the other accessories like a recovery system, hardware, rail buttons, things like that. You'll have to provide those yourself. This is essentially the sister ship to the Viper model that I've shown in a previous video. And in fact, a lot of the parts are interchangeable. And as we go through these, I'm actually going to show you how I've interchanged some of them between my Viper and this kit. When working with fiberglass, make sure that you've got safety equipment. So rubber gloves for one thing. The actual glass fibers in the fiberglass, any place that it's been cut or sanded, those stick out and they can get into your skin, cause irritation and pain. It's really annoying, so just don't do it. Also, you're going to need some epoxy, and repeated exposure to epoxy on your skin can cause hypersensitivity or allergic reactions, so that's another reason for the gloves. When you're sanding or cutting fiberglass, make sure that you wear a filter mask. Now, since I'm videoing this during the COVID-19 outbreak, everybody should have a mask handy anyway. And then also make sure that you're wearing safety glasses, especially when you're cutting fiberglass. All right, one other thing we'll need to do before we start building is to wash off the parts. And I use a fiberglass wash that is suggested by Madcow. The problem with the Madcow instructions, when you look at them, and that's one other thing this doesn't have is any instructions, but on kits that do have instructions, they say use a 3-to-1 mixture of rubbing alcohol to water. Okay, so 3 parts water to 1 part rubbing alcohol, and then a drop of dishwashing liquid. Now the problem is they don't tell you what the volume is. And so I've found what works really well is to add 1.5 cups of water, 1/2 cup of isopropyl rubbing alcohol, and then a drop of your favorite dishwashing liquid. And this is to wipe down all of the parts and remove any of the form releasing chemicals, any fiberglass dust, resin residues, things like that, that are going to interfere with the epoxy when we try to bind it. Okay, and then one last thing, when we're working with fiberglass, you want to roughen up any surfaces that are going to be epoxied. This has actually got a really smooth finish on it, and as long as you haven't broken that finish, it's safe to handle. But then since it is so smooth, there's nothing for the epoxy to bind to. So I recommend roughening up the surfaces with anywhere from about 60 to 100 grit sandpaper. I usually use 100 grit just because I keep a lot of it on hand. I do want to go through the kit just very quickly to show what it has. Okay, so we have a pre-slotted airframe, and this is a 54 millimeter diameter airframe. Okay, this is a 29 millimeter engine mount tube. We have 3 fins, a nose cone, a coupler that mounts the nose cone to the body tube, and then you have a little packet here that has the centering rings and a bulkhead in it. And I'm going to talk a little bit later on about some modifications that you might want to do to these guys. Alright, so I'm going to go do my washing here, and then we'll come back and get started on the build. So I opened up the Python kit, and this is the nose cone from that. It's actually a little bit longer than the Viper kit's nose cone, but I went ahead and ran both of them in simulation and found that the Viper kit actually flies better with the Python nose cone because it shifts the center of gravity forward and we don't have to worry about nose weight in it. When we do it the other way, if we put the Viper nose cone on the Python kit rocket, it doesn't change its aerodynamics too much because the Python has a longer body tube than the Viper does. So I think what I'm going to end up doing is go ahead and putting this onto the Python, giving it the shorter nose cone, and it's still got the fancier threaded rod and eye bolt system here that allows me to take apart the entire thing. And then on the Python, or excuse me, on the Viper, I'll put the Python nose cone and mount this pretty simply, although instead of putting the bulkhead flat up against here like this, I'm going to trim this down a little bit and actually mount it inside a little bit so that I've got more space inside the body tube for the recovery system. And the goal I'm working toward is to be able to put a 3-grain Cesaroni motor case in here that would allow me to fly at least the smaller H engines with this. So I've washed off all the dust and chemicals from all of these parts, and now comes the really messy part, where we're going to have to do some filing and sanding to make sure everything fits correctly. And if my voice seems a little bit more muffled now, it's because I am wearing a filter mask. I've got my gloves on, I've got my glasses on, and one of the first things I did here, and you don't need to do this necessarily, but on the bulkhead plate here I filled in the hole with some epoxy, and the reason I did that is I'm going to use a slightly smaller eye bolt than what this was cut for. So this was cut for using a 1/4-inch eye bolt. I'm going to use either a 3/16 or a number 8. It's not as critical here, but when we go to putting in the eye bolt for the shock cord mount, which mounts to the motor mount centering rings, there's not a lot of room there for a full 1/4-inch eye bolt. So I'm just going to use smaller hardware throughout this. For the nose cone plate here, 1/4-inch would still be fine if you want to use it. So this is set up, but it's not fully cured, and I'm just going to set it aside. Okay, next will be the centering rings. And for these, I've actually got, the kit comes with 2. I've actually ordered an extra one so that we'll have 3 centering rings here, and I'll put them all together a little bit later on, but basically there'll be one at each end and one that's offset from the middle. And the idea here is to surround the fin tabs of the fins as they go through the body tube here, to have a centering ring on either end of those fin tabs to help lock everything in place. Okay, so for now I'm going to start with filing out the inside of this. There's a little bit of residue here from when it was cut, and if we compare this, it's not quite large enough to fit my motor mount through. This part tends to be really messy, so I'm kind of clearing things out of the way. I've got some scrap paper down here, and I'm using a rounded file here. It's not a completely round file, but the surfaces here are beveled. I'm just going to use this to remove a little bit of the fiberglass here, and I'm just going to keep going around the interior circumference. Okay, now something you can see here is that these are not filing evenly. The file tends to grab and then make a little groove. So I'm going to make a conscious effort here to sand down these or file down these little roughs, the high spots, so that we get an even opening all the way around. I'm almost there. Now if you have an electric rotary tool like a Dremel or something similar, you can certainly use that. You just got to be careful that you don't remove too much at a time. Okay, so that's almost there. And for this you can still see that there's some unevenness there. And so what I'm going to do for the final part of this is take some medium grit sandpaper and just sand this around here. There we go. Okay, so there's one, and I just need to do two more. I'm not going to do them on camera here. Okay, the next thing to do then, since I've got the engine mount here anyway, is to roughen up the surface. And in fact, this will make this a little bit easier to do. But the fin tabs are going to get glued to the surface of the motor mount here as they go through the body tube. So we just want a slightly rough surface here so that the epoxy is something to bind to. Now, after you've done all of your sanding and filing, it's a good idea to go back and use your fiberglass washing solution to just wash all this stuff again to get all this fine powder off, because it will interfere with the epoxy. You don't want anything particulate on here. Okay, so that's good enough for now. And indeed, that does make that slide on just a little bit easier. Now, depending on what you're going to use for a motor retainer, you may have to sand down a little bit more along one end of this. You can actually use the Estes plastic retainers. They will fit on this, but you do have to sand this down quite a bit. But you only want to sand down the end where it's going to go on. If you're going to use one of the R.E.A.R aluminum ones, just get the one that's sized for 29 millimeter fiberglass, and that should go on fairly easily. And I'll show you both of those a little bit later as we come by. The next part that needs sanding is just right along the fin slots here. Now, I've already test fitted these, and I don't need to widen the slots any. But something to note, if I just let this kind of hang in there the way it wants to, the forward edge of the fin comes up, and that's because there's no back edge to this fin tab here. Okay, so it's not resting against anything on the back. So when we put these in, we need to make sure that this forward part comes all the way down and is smooth against the surface. If needed, you might want to take a square or triangular file and take out this rounded bit here. These were obviously cut with a router, and actually sand those so that you get a perpendicular angle there. You may or may not need to do that. That'll just depend on your own fit. But if you're having trouble getting this to fit down properly and snugly against the body tube, that might be something you need to do. Okay. From a sanding point of view, we need to sand the root tab here to just above where it'll be on the body tube on each side. And then we'll need to sand just right around here. You don't have to go out very far, but just right around the outsides of the fin slots there. And same way, use some medium grit sandpaper. And that's about it. Okay, I just want a little bit of a rough surface on either side. And on this one, the fin's not going to go past here, but it is going to come back up forward about 4 centimeters there. So you may want to just roughen up just a little bit there. Try to keep that as narrow as possible, that way you won't have to come back and fill it in with your paint. Okay, so I'm going to do the rest of these and then we'll come back and I'll do the fins, but by now I'm sure you're sick of watching me sand things. Alright, so I've sanded around the fin slots here. I've not rinsed these yet. And I've also got my fins sanded. And again, I'm just doing this mainly right along the root edges and on the fin tabs, so that when these go in, there'll be just a little bit of a rough edge there that our epoxy fillets will be able to stick to that. Okay. Now, depending on how you want to assemble your nose cone, you may or may not want to be sanding and gluing this. So if you want to make this just really structurally sound and the simplest possible, then go ahead and sand off about 2.5 to 3 centimeters down the length of this, and also sand just the very inside of the nose cone. Again, only up about 2.5, 3 centimeters, because this is going to go together like this. Okay, and so if you want to have this to be all one piece, then you would simply epoxy in here, stick that in like that, and let it harden. And then again, if you want to do the simplest route possible, sand the inside edges here of the bulkhead after you've mounted your hardware to it, and then glue that on here. Okay, now this last step right here, save till you're done with the entire model. Just on the off chance that you need some nose weight up here, which you shouldn't with this one, but in case you do this part last. That way you don't have to break this open if you find out that your rocket's not stable. Okay. What I am going to do personally on this one is drill 3 or 4 holes along the circumference here, and then mount reusable plastic rivets on here, so that if I want, I can pull this open. And there's actually a lot of wasted space in here. There's a lot of volume in this nose, a lot of volume in the coupler, that if I wanted to put like an altimeter or some other form of instrumentation in here, I can still do that. Now, the other thing I want to do with this one is I'm going to sand down the outer edge here so that this will fit inside the coupler. And I'm actually going to mount it about 3 centimeters in from the base. And then with the eye bolt there, that means the eye bolt's going to be kind of about flush with the coupler here and not sticking down into the tube. Now, in an airframe this long, that's not a big deal. But if you're doing this with a shorter airframe, that frees up a little bit more space where you can put your shock cord and your parachute and maybe an altimeter or whatever else you're going to launch in there. Something I'm going to show later on as we go through this is I'm actually making this so that the nose cone between the Python and the Viper are actually interchangeable. Okay, so I'm going to do a little bit more sanding and shaping here again to trim this down, and when we come back I'll have this stuff rinsed off again and we'll be ready for the next step. Alright, so I took the bulkhead and put it on my Dremel, and this shows both the benefits and drawbacks of using a rotary tool. The benefit, of course, is that you can remove a whole lot of material at once, and that's also the drawback. So it's got kind of a scalloped and lopsided appearance, but it does fit inside here. And what I will do here is, once I've got this positioned where I want it, is go ahead and use some thick epoxy and fill it in around there. And that'll fill in any gaps that are between the bulkhead and the wall here. Now, since I do want to be able to glue this, I'm going to go ahead and sand out the inside of this coupler. And just on this end, though, you may as well keep as much of the good finish as you can. Alright, so that's just enough to rough it up so that the epoxy will stick. And then I'm just going to mark this so I remember this is the aft end where the bulkhead's going to go. Okay, so that'll fit in there. As I said, we'll move that up about 2.5 to 3 centimeters. And then once that's right where I want it to, we'll just go ahead and stick some epoxy around that. Okay. One other thing to check on the centering rings is make sure that they actually fit inside here. Okay, and this does without any problems. But if it didn't, then just take a little bit of sanding around the circumference here. Definitely don't do this one with a rotary tool because there's usually not going to be a lot of material that needs to be removed. Okay, so I'm going to start gluing this together and rinsing off the rest of this stuff, and then we'll come back and start assembly. As I was finishing up rinsing this off, something else came to mind that normally I would talk about when we're putting the engine mount in, but just in case I forget to do that, we also need to rough up the inside of the body tube where the centering rings are going to hit. And so on this, on mine, since I'm putting in 3, they're going to be about here, another one here, and then another one about up here at the end of the engine mount tube. If you're only using the 2 that came in the kit, then I would suggest putting them here and here. Okay, now my fingers won't get all the way up in there, and so what I've done here is I've got these dowels that I mount old dummy engines to that I use for spray painting. And this is actually the subject of a forthcoming video on things you can do with dead engines. But in this case, I've simply put a little bit of masking tape on a small piece of medium sandpaper. And now I can just bring this in here and sand it up beyond where I can't get my fingers to go. And since this part of the rocket is going to have the motor mount in it, and nobody's ever going to see it, if you're not really precise about this, it's fine. Mainly, we just want to make sure there's a good contact surface for our epoxy. Okay, so now let's just take that and rinse it out again and we'll be good. Alright, so I've got my bulkhead here and I've taken a number 8 eye bolt and I've cut off most of the shank since we really don't need the length there. And so we're going to take a washer and put that on here. And then this is going to go through the hole. And my epoxy is actually a little bit soft here yet, but that's okay. Okay. And then I'm just going to remove some of that excess there. Okay, and then we'll put on another washer, and then the nut. And I'm just going to take this and tighten it a little bit here. Okay, so the threaded part here is now flush with the nut, and I was trying to do this just to keep the amount of protrusion down to a minimum. And here I just want to make sure everything fits okay. What I'm going to do next is when I go to epoxy this into the coupler, I'll also put a little bit of epoxy on here to lock that nut down good and tight. Okay, I have some 5-minute epoxy mixed up here. And the first thing I'm going to do is go ahead and put some around the eye bolt here. And all of its nooks and crannies. And I am intentionally delaying putting this around the outside of the bulkhead for just a few minutes here, because once I get it on there I want it to set up as quickly as possible so it doesn't just run through the cracks. The alternative is to use a thicker paste type epoxy, which will stay in place but is often not as strong. Okay, now I'm just going to do the nut on the underside here. And all the way around it. Just a little more here. Okay, and by doing this, not only do we secure the nut in place, but we also take off a lot of potential edges that might get hung up on something later. Now, if all you're ever going to do is just fly this with nothing in the nose, that's not a big deal. Alright, so now what I'm going to do is go ahead and start dabbing some epoxy around the edges here. And at this point, it does not necessarily have to seal completely, because I'm going to add another layer after this one sets up. Here, I mainly want to fill in the big gaps. So now I'm going to check this side again, and now all I'm going to do is just make sure if there's any drips in here, I'm just going to kind of squeegee them off. I just don't want them interfering with something later. That all looks good. Okay, so I'm going to let that one cure for a while before we move on. Alright, I've added the filler epoxy to the what will be the aft end of the nose cone coupler there. And then I've also drilled a hole in the forward centering ring, and this is what's going to hold our eye bolt for the shock cord. And this is going to go in pretty much the same way as we did with the eye bolt on the nose cone coupler bulkhead there. So I'm just going to take a little bit of my leftover epoxy and fill in the hole there. Alright, and then I've got a washer here. Alright, before I get that completely screwed down, I'm going to add just a little bit more epoxy underneath here. I really should be wearing gloves. I forgot to put them back on. Just keep the epoxy off of your skin. Okay. And now we'll put the nut on here. Alright, it's still got the coating of epoxy that was on it when I pushed it through. Okay, I'm just going to get my wrench here. Now, when I get this tightened down, I want to make sure that the eye itself is pretty much face on to the engine mount and the body tube. I don't want it perpendicular to those, or it may not fit correctly. Okay, so I'm just going to give this a little more turn there. Now, I got a little bit of epoxy on my wrench. You want to wipe that off right away, or you'll have a semi-permanent epoxy blob there. Okay, and now I'm just going to go ahead and put a covering of epoxy over this. Fortunately, there's nothing on the screw side of this that it would run into. But this will just keep it from coming loose, hopefully ever. Alright, I'll go ahead and do that down here as well. Again, kind of fill in the nooks and crannies. And unfortunately, because of the narrow size of the body tube, once you attach stuff to this eye bolt, it's pretty much permanent. Okay, so when we get all this together, this would be up here on the forward end of the motor mount, and then the shock cord will be attached here, and that'll go up through the body tube. While I'm waiting for the epoxy to cure, I'm going to make some measurements here that we'll need later on. And the first of these will be for the placement of the launch buttons that'll go into the launch rails here. And so I need to know the midpoint between two of the fins here. Okay, so spacing is right about 6 centimeters. And so if I get that right between the two, okay, which means halfway will be right here at 3 centimeters. Okay, and then I can move that out of the way. And now I can use a straight edge here to run this up. And I'm going to go ahead and run the line pretty much all the way up the body tube. I'll have to do it in 2 sections with this. Okay, so now I've got a line going all the way up the body tube, and then I'll use this to place the rail buttons further along into the build here. Now, the other thing I'm going to do with this, since I'm planning on using reusable plastic rivets to hold this in place, is I'm going to need to mark where those go. And so for this, I'm going to need a circumference here, which is right at 18 centimeters. Okay, and I'm just going to move this up just a little bit. Basically, I need this to have just enough clearance that the heads of the rivets won't interfere with the proper mating of the nose cone and the shoulder to the body tube. Okay, so if I put 3 rivets on here, then that means I need a rivet at every 6 centimeters here. The trick is keeping this nice and taut and even as we do this. Okay, so 6 would be right here. And then the next one would be at 12. It's going to be right here. And then the last one back here at 18. Okay. Now, when I drill these, I will have the shoulder coupler in place. I don't want to do it right now as that epoxy is still soft. And so that way, even if my marks were not perfect, if I drill the coupler through at the same time, as long as I get them aligned the same way each time, then it'll still fit without any problems. And we'll even make a little line on one of these to indicate where to line up with the collar each time. Alright, and then that would be going on here, all the way up. And notice how springy that is? Alright, that means I've got a good seal on my epoxy there, so it's almost airtight. And what we'll need to do is actually put a little vent hole in here so that we don't have the problem when we go to launch. We'll do the same thing on the body tube as well, so that if this goes up really high in altitude really quickly, the pressure inside the body tube doesn't prematurely force the nose cone off. This is something you usually don't have to worry about too much in model rocketry, but as you get up into high power, mid-power rocketry, things are going fast enough and the materials like this aren't porous at all. And so we have to make up for that by putting a little vent hole in there. Alright, so my coupler was cured enough that I could work with it now. And so what I did first of all was to put just a very small hole in here to act as a vent so I could move the coupler in and out without building up pressure. Okay, the rivets I'm using are these guys. It's a 5mm diameter and a 6.5mm length. And so that should be just long enough to poke through both layers here and still provide a good friction fit. And so I've drilled out each one of these. And I've got one button in here already that I'm using as a placeholder. Now you notice here there is some roughness, and we'll need to go in with a modeling knife or something and clean some of this stuff out. But I just want to show you how these go in, and I'm going to take it apart again. So the first thing you want to do is pull this little plunger out, almost all the way out. Basically it needs to be up past the split here in the rivet, and then this just pushes in. Just kind of wiggle it in. You don't want to push too much on the plunger here until the shoulder's all the way in there. And then you just push this in firmly. And it rests nicely against there. You don't get a whole lot more drag. It's nice and rounded. And this will give actually a really nice professional finish look to it, while still allowing you to get access to the nose cone and the coupler from inside here. Okay. To take these off, you simply pry them up, use a knife blade or something like that. Do it carefully. And you can get these, I got these on Amazon. You can also find them in some auto parts stores because they're used for holding on trim. And then if you absolutely can't find them anywhere else, Apogee has one size. I think they're 4.5mm diameter, which is where I first got the idea, but then I had to look around to find other diameters. Alright, so once you got this up, unfortunately, this is very tight, which is good for holding it on, but if you need to get in and out of this a lot, you might consider using a slightly smaller diameter one that's a little bit longer. Okay, but those do come out again, and these can be reused multiple times. Eventually the plastic will probably crack on you, but you just keep a few of these in your launch box and you'll always have a spare ready to go. The epoxy in the nose cone has cured overnight, and we've set that aside. Here I have the motor mount now with all of the rings properly sanded and sort of in place here. So this is just dry fit to put it all together. And remember I said I'd purchased an extra ring here so that I could have 3. And the reason I like to do this is so that when I mount this, I will have a ring on each end of the fin tab that will go in here, and then I'll also have a ring further up here to strengthen the motor mount around the eye bolt here for the shock cord. Now if you only have the 2 rings, then this eye bolt will go down here, and you'll have to make the choice as to whether you want the ring down here to help strengthen your fins, or if you want the ring further up so that you've got less interference potentially between the shock cord and the motor mount tube here. Either way you do it on this model is probably going to be fine. I really like to have both though, and so with the expense of just a few dollars I can get the extra ring and stick that in there. Okay, and then if we measure this against the fin here, alright, so when I stick that fin in, it's going to be resting against the motor mount and in between the 2 rings here. Now, something I brought up earlier was the rounded cut here means that I can't quite snug this up against the motor centering ring. And so what I'm going to do is just take a file and square off this corner here, and that'll allow me a tighter fit. While we're doing this, we also want to look at motor retention. There's no motor retainer in the kit, and I've got here 3 possibilities. Now there's a 4th possibility too, in that you could just use a friction fit and tape the motor in. That's by far the least expensive, at least in initial outlay, but if you blow out a reloadable motor there and lose it, then you're out a whole lot more. So I've got 3 different choices here. The one in the middle is actually made by Madcow, and what this does is you put these little threaded nuts into the rings like this. Okay, so you have to drill these in, and then the retainer is this metal piece, so it goes over those like so, and then the screws go in to hold the motor in. Okay, this is the most complex, and this runs around $12 for that, so it's not too bad. This is an Estes Proline 2 motor retainer. It's made out of plastic, and this, to use it with the fiberglass here, you need to sand down the edge here a little bit and remove about 1/2 millimeter or so of material all the way around, and then this just gets epoxied on. This is the least expensive of the 3. These are about $5 for the set. And then related to this, this is the R.E.A.R retainer. This works in the same way as the Estes one, except it's made out of aluminum. And this is the most expensive of the 3. This is, if I remember right, a little over $20. It's also by far the easiest to put on. So this is actually sized for fiberglass motor mounts. You can also get them sized for cardboard ones. And this, I don't have to do any sanding. It fits right on there. You just have to epoxy it on, and then you stick the motor in and screw this on. Okay, so 3 possibilities here. I think for now I was thinking I was going to do this one just because I've never used one of these before. I wanted to try it out. but it's really kind of tight in there. And so I think for this model I'm going to go with the Aeropack one or the Estes one. So I'll just put these away for now. Now something I am going to do here, and we can actually use this as a template. And if you are going to use this Madcow one, you get two bonuses here. So not only do you get the retainer, but when you put the holes for mounting in this, you can use this as a template. So just get it centered on the back side and drill your holes here. What I'm going to do here, even though I'm not using this, I'm going to put two small holes in this, and what this will allow me to do is glue on the first two rings of my motor mount, get them fitted inside the body tube and glued in like so. And these are going to slide all over the place, but for illustration here. Alright, so once I've got that where I want it, I can have the epoxy in there setting, and what I'll do is run a piece of string between the two holes there, and this will allow me to temporarily put this into place to help keep the motor mount straighter while my two forward rings are curing. And then when I'm done, I can take my string and pull this thing out, and the advantage to doing that is it will give me access to the fin tabs. So if you just glue this whole thing in at once, you're having to rely a lot on getting enough epoxy on the edges there to put this in. Okay, but if I've got access here, I can put my fin in, and now I can put internal fillets inside that will do both the adhesion of my root edge to the motor mount, and I can also have an internal fillet for the body tube to the fin tab as well. And then when I get done with that, I can put another fillet on the outside, adhering it to the outside of the body tube. So then my fin's going to be attached basically in three different places, and it's going to be nearly impossible for that to come loose.